Hello everyone, how's it going? Welcome, welcome, welcome. Today we're going to be doing another lab together using Packet Tracer. We're going to be doing one of Keith Barker's labs again. This is the fourth in our series of doing labs together. And just like before, the plan is for me to run through a Packet Tracer lab, run through various commands to configure and validate the configurations that we're going to be doing. And then I will talk through things you can kind of learn from the different show commands and how to verify what's going on with the lab and prove to yourself things are working the way they are meant, rather you mean for them to work. Just like before, I like to focus a lot on understanding the distinction between a device's configuration and a device's operation. Those are two very distinct things. Sometimes a device is configured a certain way but isn't exactly operating that way. There's various show commands you can use to kind of validate one versus the other. So that'll be a large part of what we're going to focus. Yeah, I guess we're going to get right into it. So I'll show you the lab we're going to do, and then I'll talk to you about what's happening next for this series. I'm pretty excited to show you what the fifth installment of this series is going to be, but stay tuned for that. During the lab, again, if there's any questions on anything insofar as how topologies work or how technologies work or protocols work or whatever, feel free to just throw them in the chat. I'll check in with that periodically. With that said, let's get into the screen share. Cool. So again, we are going to do another lab from Keith Barker. This is Keith Barker's website, thekeithbarker.com. He has a bunch of cool resources. If you're trying to study the CCNA, I would definitely recommend checking some of those out. One of them, if you go down here to the downloads section, that'll scroll down on his website to this section. And this is where he has a bunch of Packet Tracer labs that you can download and practice configuring and working your way through yourself. These are one of the labs that we're going to be doing today. Now we did a bunch of these in the past. Let's see if I can find them. I think we did this one for the second installment, this one for the first installment, and then this guy was last week, and today is this guy. So this is the one we're going to be working through today. So I'm going to go ahead and download this guy. Open up the zip file, it downloads. There's two things in here. There's a PDF, which includes the instructions, and it's already kind of in the right place. We'll have that in the bottom left corner for our lab, and then obviously the actual Packet Tracer file. So I'll double click that guy, get it started, and we'll go into it. Now, I am running Packet Tracer version 8 point something or other. You can see that down here. I believe Keith created these in version 7.3, if I recall. Either way, if you're using an older version of Packet Tracer, some of the stuff might not work as it does for me today. So I would definitely recommend upgrading to the latest version. If you want to work through this lab together while I'm doing it, that's awesome as well. And obviously, if you're joining us in the recording after the fact, you can always pause, work through the lab yourself, and then see me go through it afterwards. With that said, let's get right into it. So in this particular lab, Keith also included the instructions in the Packet Tracer background image itself. Since we have the PDF open, we're actually going to move everything off screen so that we can kind of have everything in their own little windows. So we will get our topology work or looking cool. When I'm doing labs, I typically like seeing both the instructions and the physical topology at the same time. And so this is why I take, yeah, it looks like you guys can see everything. Awesome. All right, so we don't need that, and we're not going to need that until later. Okay, so let's look at what we have. So in the lab, we've got these two switches, and then so these two switches are the icon for layer 2 switches, so we know no routing is happening there. And then we have a proper actual router, so presumably this router is going to be routing between all the different networks that we have in this topology. Looking at the lab objectives, what we're going to have to doing is putting PC 1 and 3, that's this guy over here and this guy over here, in VLAN 50. And what I'll do is I'll put these a little higher so we can know that they're in the same VLAN, and I'll put these down here so we know that these are going to be in the same VLAN. And then PC2, and PC4 are going to be in VLAN 60. Would this look too messy if I do this? Yeah, it would. I don't want to do that. Cool. So the higher PCs over here are going to be in PC10, sorry, VLAN 50 rather, and then the lower ones, PC2 and 3, will be in VLANs 3 and 4. The PCs are all going to get addresses via DHCP, so we'll have to make sure DHCP is configured correctly on the DHCP server. And it looks like the DHCP server is meant to be in a different VLAN, VLAN 70, with this IP space over here. And since the DHCP server is in a different VLAN, that tells us we are going to have to set up DHCP Relay on our router, on our layer 3 device. The default gateway is going to be the first IP in each subnet. That's going to be useful because we'll probably have to configure the router with that first IP address. No Stp Blocked Ports. The indication there is the two connections between those two switches are probably going to have to be set up as an EtherChannel. So we are going to also make sure we do that. And then obviously the verification at the end is can the clients all ping each other and can the clients access the web page at keithbarker.com. Okay, so that's the basic rundown of the plan for today. Let's jump on the web server real quick. I want to see what's actually configured to start. So right now, it looks like the web server doesn't have an IP address. And if we look at our topology, it says that the web server has the last IP address in VLAN 70. Now, since it is the DHCP server, it doesn't make sense for the DHCP server to also get an IP address from DHCP. So I think it's safe to say we're going to have to statically configure this particular IP address. Now, since the IP address, so we're going to have to do a little bit of subnetting. So this is the last IP address in VLAN 70. This is the IP subnet for VLAN 70, so 10.67.83.32, 67.83. So this is a /28 network. A /28 network has a group size of 16. So if we do this network ID, .32, plus 16, that'll take us to 48. That's the next network, the next /28 in the series. The IP address right before that, which would be .47, would be the broadcast IP address, which is not usable as a host IP address. So when this bullet here says the last IP, what it's going to be looking for is .46. And then the mask is going to be 255.255.255.240. I'll do a quick shout out if you're unsure how I was able to kind of put that together so quickly. Definitely check out the videos at subnetipv4.com. It's the Subnetting Mastery video series, and I think it's one of the best resources you'll come across for how to subnet. So definitely check that out to understand how I got to what I got just now as quickly as I did. So that's that. We'll also have to set up the gateway statically. The IP address is going to be the first IP address in the network. So .32 is the network ID. So the first usable IP address in the network is going to be .33. Cool. So at least that's configured. And let's also take a look at the services running. So if we go to HTTP, this is meant to be our web server. So it is. So it's not running HTTP, it is running HTTPS, so we'll have to keep that in mind. We are connecting securely. If we open up the DHCP tab, we'll see there is one DHCP pool configured for, looks like VLAN 70's IP space. We'll have to configure some for PC 1, 2, and 3, and 4 with VLAN 50 and VLAN 60 IP space. And then DNS is turned on, and it does have an A record for the keithbarker.com. So we will have to configure DHCP on the server, but let's not start there. Let's start with layer 2. So if we jump on this switch, jump on the CLI, you'll notice it's got the default switch prompt right there. This tells us this is a brand new switch. Well, doesn't tell us directly, right? But for the most part, you can assume that this means this is a brand new switch, which means we're going to have to do all the configurations from start. And a great place to start with those configurations would be, let's make that a bit bigger, would be to disable IP domain lookup. So if I mistype a command right now, what the device is going to try and do is look this up in DNS to see if that's actually something useful. Obviously it's not, but this takes a bit of time, and no one's got the patience to wait that out. And so that's why it's good to note when you see that you're configuring something from scratch, that you're going to be that a good place to start, I should say, is to start with kind of like your basic configuration sets to disable things that do. So see, like it's still actually going right now. So this trick is actually Keith Barker's trick. A good option you have is to just pop on a notepad and then kind of type in all those pre-configuration options that you just want to get rid of and apply to all your devices up front. So for starters, I'm going to do a couple enters. Then I'm going to do enable. I'm going to go to configure T. Then I'm going to do no IP domain. Oh, where's the dash in this command, man? Is this still going? Okay, cool. So this is the command we're looking for right here. I always forget whether the dash goes here or the dash goes here. Domain lookup. So we'll disable that. What else do we want to disable? The lab didn't give us instructions on whether we're using regular spanning tree or rapid spanning tree. So let's go ahead and enable rapid spanning mode rapid. Just to make sure I got the commands right, spanning tree mode rapid. Cool. So you see I'm kind of shortcutting the commands a little bit. You know, it probably shouldn't if we're just going to copy and paste this. So maybe we won't shortcut the commands. So we'll make that rapid. We'll also make all the access ports there, port fast default. And what this is going to do is make it so that all the access ports are automatically in port fast mode. This will just make them come up right away if something gets plugged in, so we don't have to wait through listening and learning states and all that fun stuff. And then from there, we will jump into line console 0, and then we'll disable the exec timeout, and then we'll put ourselves in privilege level, if I spell it right, line con 0 priv level 15. So again, I'm making sure that I'm building this template out correctly with the right spelled, with commands spelled correctly. And then we'll turn on logging synchronous. This will make it so that the log messages don't appear in the middle of our command. And then from here, we'll get out of line console 0. And then we will, I guess, set a host name. And I'll leave the prompt right there so I can type the host name in myself. So let's go out from the very beginning. I'll paste all that in. It'll apply all that stuff in one go. And then this right here is switch 1. So there's my host name. There's the validation that we are on switch 1 at the top. I'll save that. And then here I'll do the exact same thing. We are on switch 2. Cool. So that takes care of that. Now I'm going to jump on the router real quick just to make sure to see if it's the same, meaning we're on a default router. It looks like we are. So again, we're going to start from scratch. I'm actually safe to just use these exact same commands, except the spanning tree ones are sort of irrelevant. Whether I leave them or not, it's not really going to hurt anything, because if I leave them in place, the router's just going to be like, hey, that's not a real command, because routers don't really, oh, I took the command. That's interesting. I would have expected them to error out, but very interesting. What version of the router is this? Either way, doesn't hurt anything, so that's in place. Cool. So let's focus on the switches at this point. All right, so that's all the basic stuff, and now we can actually get into the actual configuration of the switches. So to start, I'm going to need 3 VLANs on each switch: VLANs 50, VLANs 60, and VLANs 70. So let's take a look at show VLAN brief to see what's configured. And as expected, there are no VLANs configured since this is a default switch. So I'll configure these: VLAN 50, VLAN 60, VLAN 70. And I'm going to do the same over here: VLAN 60, VLAN 70, VLAN 50. And then we'll do show VLAN brief, and now we can see that the VLANs are indeed created. There are no ports in those VLANs at the moment, of course, because we haven't actually added any. Show VLAN brief. We haven't added any at this point, which I guess we can do next. So it looks like PC1 and PC2 are on ports 1, and I'm guessing that's 2. Yep, that's 2 over there. and then PC3 and 4 look like they're also on port 3 and 4. And we can validate this if we do a show in status on switch 1. We can see that there is something connected to port 1 and 2. Presumably that's our two PCs. Currently that something is in VLAN 1 since it's default configuration. And if I do the same thing, show in status over here, we have something connected to port 3 and 4. That's PC3 and 4. We also seem to have something connected on port 5. That's probably our web server. Yep, that's our web server. So we'll have to remember that. Cool, so let's jump into it. So I'm going to jump onto FA01. I'm going to make that an access port. And then I'm going to jump into FA0. Oops. And I'm going to put that access port in switch port access VLAN 50. And then I'm going to jump into FA02 and do the same. But first, let me show you something. So show int FA01 switch port. Here's how you would verify what we just configured is operating the way we want it to. So this command, show int switch port, and then we filtered it to just this interface using that syntax. It's telling us that this port is configured as an access port and operating as an access port. Cool, that's exactly what we want. That confirms that's what we want. And it is currently in VLAN 50. That again confirms that's what we want. If I did the same thing for the port I haven't configured yet, FA02, you'll see that it is in its default configuration mode of DTP dynamic auto. And it has currently negotiated itself into an access port because the other side is in a trunk. Now the other side is facing a PC, so PCs don't do DTP, so we know it's going to default to access port. But again, it's trying to negotiate into a trunk, but you could say failed to in this particular case. Now we want to disable that. We want to statically set things because we don't want the switch trying to automatically guess what port it should be. So we're going to statically set that to a trunk. And obviously we're going to change the VLAN it's in from 1 to, in this case, VLAN 60. So int FA02 switch port mode access, that'll statically set it to a trunk. And then switch port access VLAN 60. Now if I do show VLAN brief, we can see that port 1 and 2 are indeed in VLAN 50 and 60 respectively. Cool, so we'll save that. Go down in here and I'll do the same. This is going to be ports 3 and 4, so switch port mode access, switch port access VLAN 50, int FA04, switch port mode access, switch port access VLAN 60. Show VLAN brief, and then we see a port in VLAN 50 and VLAN 60. So that's good. That takes care of essentially these two bullets, with the exception of IP addresses, because we haven't configured our DHCP server pool for the other IP addresses or our DHCP relay. So we'll get back to this. Let's finish on the layers 2. Excuse me. Finish all the layer 2 stuff. We actually already took care of that. We'll do layer 3 in a minute. Okay, so no Stp blocked ports. So if you look at the packet tracer analogy, you'll see one of these interfaces showing up as orange. What's happening? Oops. So yeah, instantly it failed out of this when I mistyped this. That's because of that no IP domain lookup that we did. In any case, what's happening if I do show spanning tree VLAN, let's just say 50 or 60. Oh, that is very interesting. Oh, those interfaces. I get it. So if we look at, let's do it this way. We do show CDP neighbor. We see the ports, the switches are connected to each other on port FA022 and 11. And if we look at those ports right now, they are showing connected. There's 11, but you'll notice that they're in VLAN 1. That's why we're not seeing anything when we're taking a look at the spanning tree information for VLAN 50. If we looked at it for VLAN 1, we would see those ports. There's FA11 and FA22, and you will notice in this particular case, this is the root bridge, so nothing is blocked there. But if we, oops. But if we jump on switch 1 and do the same thing, show VLAN, show spanning tree, VLAN 1, I was right. You'll see port 11 and 12, we do have a blocked port. port 11. So to undo this, essentially we have to put those two ports in a port channel, so the switches consider them as a single port, and then there's no loop, and therefore there's no port for spanning tree to bring down. So what we are going to do is we'll use the range configuration to kind of configure them all at the same time. We'll configure both FA011 and FA022, and we're going to put those in a channel group. The channel group number I use is sort of irrelevant. Let's just go with 3 just for kicks. And then we will call, and then we have to specify the mode. And this is going to determine if we're using PAGP or LACP to negotiate the port channel. For our case, we're just going to keep it simple and just say turn it on. Don't worry about the negotiation. And we'll do the same thing down in here. Int FA0, int range, FA011, FA022, channel group mode, forgot the number, 3 mode on. So now, if I scroll up, you'll see before, this is what we saw. Actually, this will be more interesting. If I scroll up, you'll see this is what we saw on the spanning tree output. We saw, one port blocked, the other port enabled. And now if I do show span VLAN 1, you'll see there's only a single port, and it is currently still showing up as alternate. But it's not blocked. Cool, so progress. I imagine that's also going to change when we set that interface up as a trunk. So that is the port channel. So next we're going to do is set that port channel up as a trunk. So I'm going to do int PO3. And real quick, I actually want to show you something. If I do a show run, you'll see that I currently have nothing configured in the port channel. And if I go down to FA11, the physical interface in my port channel, there's only the command, which puts it in a port channel, and same thing for 22. But if I go into the port channel interface and I apply configuration, so switch port mode trunk, you'll see now if I do show run, that command replicated itself into the physical interface commands as well. So FA011 and FA022. We can validate that it took by doing a show int trunk. This is telling us port channel 3 is indeed configured as a trunk and has indeed negotiated, rather is indeed a trunk is how I should say that. And I'm going to do the same thing over here, int PO3 switch port mode trunk, right mem show int trunk to verify. Cool, so this looks good. And now if I do show span VLAN 1, cool. Those are both showing up, show span VLAN 1. Cool, that's probably a little bit more relevant. Show span VLAN 50. I don't think we have any ports in VLAN 1, so nothing's going to show up relative in VLAN 1. Cool. So that takes care of the port channel and the no blocked ports. We set up the trunk in between the interfaces. I don't think we ever put the web server in its in VLAN 70. So let's go ahead and do that. So that's plugged into switch 2. If I do a show in status over here, we will see that port 3 and 4 are in VLAN 50 and 60. Port 5 is currently connected, but in VLAN 1, still in the default. So we need to move that to VLAN 70. Conf T, int FA05, switch port mode access, switch port access VLAN 70. If we do show in status, we'll see that did indeed took. And if we do show VLAN brief, we'll again see that we now have a single port in each of those interfaces. Single port in each of these VLANs is what I meant to say. Cool, so that takes care of that for layer 2. And the last thing we want to do is actually back on switch 1. We want to make sure that switch 1's trunk to the router is configured as a trunk. So if I do show CDP neighbor, I currently don't see the router. Oh, this is the old entries from before we made it into a port channel. If you fast forward time a little bit, thank you, Packet Tracer, those will go, wow, those may go away if not for so this is probably a packet tracer-ism. So I mentioned this in one of the other walkthroughs. Packet tracer is a lab simulator, not a lab emulator. So things like GNS3, EVN-G, Cisco Modeling Lab, CML, those are lab emulators, meaning they're actually taking router code and switch code and running that code, which means that what's happening in those labs in GNS3 and EVN-G and those is almost exactly what a actual Cisco live physical device will do. Packet tracer is a lab simulator, meaning it's pretending to be a router and pretending to be a switch. That's why it doesn't have all the features of a real switch and all the features of a real router, because that simulator wasn't built for all the features. So sometimes you're going to run into these weird oddities with packet tracer that wouldn't exist in the real world. And this right here is one of them. As packet tracer seems to continually show you the CDP entries on the physical interfaces, when at this point we've set up the port channel for the link between switch 1 and switch 2. So that is what's going on there. In any case, let's finish setting up our trunk. So it looks like the ports are gig 1 to gig 00. Now the fact that this is red over here in packet tracer tells me that it's shut down, probably on the router, because router ports start shut down. But if the actually, is it going to tell us that it's connected? No, it's not. So we know from the topology that gig 01 is the one that we want to set up as a trunk. So let's go ahead and do that. Conf T and gig 01, switch port mode trunk. Now we probably won't see it. Yeah, we're not going to see this here because the interface is still down because the other side has not been lit up. So since there's no signal, no current on that wire, the interface is down and that configuration won't actually apply. So with that said, we can now move on to the router. So let's configure the router, and I'll put the router down here. Cool. So we'll take a look at what we have first. And it looks like indeed gig 00, which is the interface on the router we're plugged into, is currently disabled. It's shut down, so we're going to have to turn that on for starters. And then some basic commands you want to do when you jump on a router, just to understand what the router is doing. Show CDP neighbor, obviously. Oh, that's interesting. It's not even enabled. So let's turn that on. That's a good one. Show IP route. Currently right now, nothing's going on because none of the interfaces are up. So sweet, that's as expected. And what else would be good? Show IP protocols would be good for routers, just to see what sort of routing protocols are going on. Now, obviously, in this particular case, there's only one router, so we know all those commands aren't going to show us much. But those are kind of like the general commands I would run when I jump on a router that that I haven't already been configuring, just to get an idea of what's going on said router. So with that said, we're going to have to configure IP addresses for each of the VLANs. And since the router is connected to the switch once, we're going to have to do, just like on the switch, we configured it as a trunk so that all VLANs would go down that trunk. With the router, the equivalent configuration to that is what's known as router sub-interfaces. So we're going to have to configure that for each of those interfaces. Now, if you haven't seen this document, I wrote this article a few years back, I guess back in 2016, but essentially outlines all the different ways that you can route between VLANs or do inter VLAN routing. To beginning with starting why you need to route between VLANs, right? And I go through this kind of demonstration where if you have this as your topology, you have two physical switches and these hosts connected to these switches. In order to get traffic from this switch to this switch, which are on different IP networks, you'd have to put a router in between them and connect them the same way, and rather connect to each of those switches. Well, this topology is logically representing a single physical switch with two VLANs. So just like in this topology, you would need a router to let those, A and B speak to C and D. You would need to do the same thing in this topology. Then the article goes through the three different options you have. The first would be taking a router and putting a new physical interface in each of those VLANs. That would actually work. I would show you how to configure that on the switch, how to configure that on the router, as well as some of the commands to verify that things are working. The option we're going to be using is this guy right here, is a router with sub interfaces. And so what this means is we're going to have this router connected to the switch once, and then we're going to tell that router to send traffic for multiple VLANs down that single connection. Just like, if I scroll over here, just like we have over here, a single link between the router and the switch. And the configuration for that is what's known as sub-interfaces. So I talked through the configuration on how to configure that, the encapsulation.1q command, and then we run through some show commands for how that works. So that's that article. I'm going to throw it in the chat if you're interested. Highly recommend this guy if you're studying VLANs. So that is essentially what we're going to be doing on this router as well. So first I'll go into the physical interface and I'll turn it on. Yeah, for sure, Edwin, you're welcome. So first I'll go into the physical interface and I'll turn it on by doing a no shut. Now if we jump on switch 1 and we did a show CDP neighbor, I imagine now we would see the router. In any case, that's the physical interface. Now I want to configure each of the sub interfaces within that physical interface. And the way to do that is to use the same interface configuration, but add the little dot, which is called the sub interface distinguisher, and then throw a number. Let's see if I do a question mark, will it show me? It won't. Throw a number there. Now I chose .50 because we're going to configure this particular sub interface for VLAN 50, but the number you choose is actually entirely irrelevant. The number that actually matters is what I'm going to type next. So we've created the sub interface, but now we need to tell the router what VLAN that sub interface is going to represent or terminate. And the command for that is encapsulation, and then the encapsulation mode, there's only one, .1q, and then the VLAN itself, we're going to call it 50. Now, most of the time, this is going to match this. But again, this right here is just a distinguisher. It doesn't really matter what number you put in. You can put in any number you want. And I'm going to show that to you in a moment. This is the actual number that matters, that tells the router this interface is in this VLAN. Cool. So now that we know what VLAN it's in, now I need to give it an IP address. So IP address, if we go down in here, VLAN 50, this is the IP space for VLAN 50, and then this hint right here says that the default gateway for for each of the subnets is the first IP in the subnet. So if this is the subnet, we know that this is going to be the first IP address in 1067.83.0/28. So 1067.83.0 is the network ID, can't use that. The next IP address .1, that's the first usable IP address. And the mask is /28, so 240 as the subnet mask value. I'll hit enter there, and then I'll do show IP in brief just to show you what I've configured. And you'll notice we have a sub interface configured with this IP address. And if I do show, what else can I do? Show run. We'll see here is our physical interface, and then here's the sub interface we have just configured. Now we're going to do the same thing for VLAN 60 and VLAN 70. So I'm going to do configuration, go into global configuration, and gig 0.0.60, encapsulation .1q 60, IP address 1067.83.17. I know it's 17 because the subnet is .16, and since this has to be the first IP address in the subnet, that would be .17. Mask is the same. And then I'm going to do VLAN 70. Now I'm going to do something interesting. I'm actually going to give it the number of 7070 here, just to show you that that number doesn't really matter. It's just there to distinguish one sub interface from the next. The number that matters is this guy, and I have to make that guy 70. And then the IP address for this guy is going to be 1067.83.33. And I'm getting that because I know VLAN 70, the IP space is right here, and this is going to be the first IP address in that IP space, so it'll be .33. Cool. So show IP in brief. I've got the way it like bleeds into that. So I've got 3 sub interfaces configured with the IP addresses 1067.83.1, 1067.83.17, and then 1067.83.33. So now that we have physical / sub interfaces configured, if I do a show IP route, we can expect to see directly connected routes for each of those interfaces, and that's what you're seeing right here. One directly connected route for every network that I have a IP address in for this router. Cool. Now, at this point, if we've configured everything, we should be able to ping the web server. Remember, we gave the web server an IP address, the .46 IP address. Ping 10.67.83.46. So let's just see if we have configured things right. Awesome. First one failed because of ARP, and then the rest all succeeded. So this tells us we currently have connectivity from our router to our web server. Now, just for kicks, let's validate routing. So I'm going to jump on the web server itself. Uh-oh. Man, I really don't like the Windows arrow feature that does that. Super annoying. In any case, so now I'm on the web server, and what I want to do is see if the web server can ping the router, which technically, since the router can ping the web server, I already know this is going to work. But what I want to see is if I can ping through the router. Now, none of the PCs have IP addresses yet because they're all going to get IP addresses from Dhcp, but I can ping the other interfaces on the router. So ping 10.67.83.33. So that's the router interface on the same VLAN or in the same subnet as the switch. This of the web server. This is the one that I know is going to work. Here are the ones that I don't yet know are going to work. It looks like this does. This does tell me that routing to some degree is working. At the very least, from the web server's perspective, the default gateway is configured correctly. I can access IP addresses that are not my own local subnet. But now we want the PCs to be able to do that as well. So we are going to now configure the DHCP pools on our server. Make that a little bit bigger. Cool. Cool. So first, oh, I didn't see this earlier. Notice DHCP isn't even turned on. So that's a problem. So let's go ahead and turn on DHCP. I'm going to create a new pool. We'll call this, DHCP IP addresses for a VLAN 50. The default gateway is going to be the router's IP address. So the first IP address in VLAN 50, which is 10.67.83.1. The DNS server is the web server we're currently configured, 10.67.83.46. The start IP address for VLAN 50, 10.67.83. That was pre-populated from before, so that's a different VLAN. So VLAN 50 starts at .0. .1 is in use. That's the router IP address, so I definitely don't want to start at .1. So I'm going to start at .2. This is the mask for VLAN 50. Maximum number of users, I'm going to say no more than 10. So a /28 or a .240 network has 16 total IP addresses. 14 of those are usable. One of those is assigned for our router, the first IP address in the list, which leaves us with 13 left over for host. And I'm just going to assign 10 of those 13 just for kicks, in case I need those 3 to statically assign later on, if I want to add hosts or add servers or add printers or something like that. Cool. So I'm going to hit add, and now that's in place. I need to do the same thing for VLAN 60. The default gateway is the same. Default gateway is not the same. Correction. That's .17. DNS server is the same. Start IP address is going to be 18. Again, we don't want to give away the default gateway IP address. Number of hosts also 10. That's totally fine. That all looks good. I'll click add again, and now we have 2 additional pools configured on our DHCP server for VLANs 50 and VLAN 60 respectively. Cool. Hello, VAMC. Welcome from Germany. Welcome. Cool. So that's DHCP. Now the last thing we're going to have to do is set up a DHCP relay. So right now, all these PCs are currently configured for DHCP. So if we go to configuration interface, oops, they're not. They're configured statically. So let's tell them to get their IP addresses via DHCP. What you're going to find is that's not going to work. So if I come down in here, you'll see as soon as I told it, look for an IP address with DHCP, it picked out this 169.254 address. That address is an indication that it was unable to find a DHCP server. The way most hosts behave is that if you can't find a DHCP server or can't get an IP address from a DHCP server, it'll pick an address from this range, from 169.254/16. So that's PC4. Let's make the rest of them also use DHCP. PC2, fast interface, DHCP, PC0, configuration. That guy's already DHCP. Awesome. Now, even though we've configured the DHCP server correctly, and we've told the PCs to get IP addresses from DHCP, what's happening is they're looking for a DHCP server using broadcast, which means their traffic is going all throughout wherever VLAN 50 and VLAN 60 exists, but it's not crossing into the VLAN 70 because the router is not going to forward a broadcast across the routing domain. So what we need to do is tell the router to act as a DHCP relay or a relay agent. And what that means is whenever the router sees those broadcasts, we want the router to take that broadcast and then forward it to the actual DHCP server that could exist somewhere else on the network. So that's what DHCP relay is. So we're going to be doing that on the router. Cool. The commands for that in the Cisco world is IP helper addresses. So we're going to go into each one of those interfaces we configured. So show IP in brief. And then we'll type IP helper address, and then we'll provide the IP address of the DHCP server. So 10.67.83 dot, which was 46. And then we'll do the same thing for int gig 0/0.60, and I can just do up arrow. And I don't need to do it for this guy because there's no DHCP clients on that particular network. So we'll do that. And if we come down in here and then now just tell it again to find an IP address via DHCP, you'll notice instantly it was able to find successfully an address. And the last test is just to make sure everything has connectivity. I'm going to fast forward really quick just to make sure all the PCs have also picked up addresses as well. And then I will go to the router and do this cool trick. We saw this trick last week when we went through another packet tracer lab, where if you have a single device doing the routing, that single device can ping everything in the topology by shooting a ping to 255.255.255. This is sort of to understand what exactly is happening here. I'd point you to understanding the difference between a local broadcast and a targeted broadcast. And for that, I can just give you the local broadcast, directed broadcast. Cool. If you go to this article explains everything to do with broadcast, how it works, what a layer 2 broadcast is, what a layer 3 broadcast, what you can do to speak to who with a broadcast. It shows you the packet tracers, it shows you the headers. It kind of picks it apart in great detail. I'll again throw that in the chat if you guys are interested. In any case, if we look at the output, we'll see, so this series of pings, we had 5 responses, 2 of them from devices in this network, which is VLAN 50. So we can presume that to be PC 1 and 3. And then 2 of them from these IP addresses. These are the IP addresses in VLAN 60. We can presume those to be PC 2 and PC 4. And then, of course, our web server with the final response. So I now know that my router can ping everything. Let's jump on one of the PCs and see if the PC can also ping all the other devices. So what I'm going to do is essentially just ping every device on this list in that set of 5. So ping 10.67.83.46. That looks good. Ping, and then I'll do .18. That looks good. Then I'll do .19. That looks good. Then I'll do .2. That looks good. And .3 also looks good. So I know that PC4 can now ping through the router every other PC and the web server in this topology. So that takes care of this objective rather. And the last one on this list is making sure the PCs can access the website. So if I jump back to PC4, go to the web browser over here, and the website is https://thekeithbarker.com. Looks like it loaded. We are happy with that. So going back through the objectives, the PCs are indeed in those VLANs. They did get IP addresses from DHCP. The web server did indeed have the last IP address in VLAN 70. The default gateway was configured correctly as the first. We don't have any Stp Blocked Ports. Notice everything is showing green. Clients can ping each other. Clients can access the website. And we have now completed this lab. And so that is everything we meant to do in this particular lab. So with that said, I'll now turn it over to chat. What do you guys think? How did that go? Did you learn something? Did you enjoy that? Do you have any questions? Feel free to throw anything in chat. And then I'll tell you what's happening next week, which is actually I'm pretty excited about. All right, so I'm not seeing any questions in chat, so let me show you guys what's happening next week. So this is the 4th installment in this particular series. The 5th installment is actually a lab that I designed myself. In this installment, I'm going to open up the packet tracer right now. Here's the lab that you're going to have. Now this looks like a complete jumbled mess, and to some degree it is, and it's meant to. But this is meant to replicate what you would have in a real real kind of network environment for a network that you manage or you get hired for or whatever. The scenario essentially is you have a bunch of people plugged into your network, all these PCs over here, and for some reason you get told that certain of those PCs are, sending malicious traffic or whatever. And your job is to find where those PCs are in the network and shut down those ports. Now, obviously, you and I can just jump on the PCs and find, figure out which one has the IP address or MAC address that we're trying to find. But in the real world, you have to think these PCs, these hosts, are like people's phones and people's laptops and people's whatever that have passwords on there that you can't access. So this particular scenario is meant to go from the perspective of you cannot access these PCs. All you have is access to the network environment. And what you're meant to do, if you follow through on these steps, is jump on this switch and essentially trace where in the network a particular MAC address is, and then kind of use that knowledge to then jump on the next switch, jump on the next switch, jump on the next switch, and then finally shut down a particular port where the bad PC is, which I'm colloquially calling the imposter. That's the plan for next week. Now, I'm still tweaking a few things insofar as like the instructions and the packet tracer, so I'm not quite ready to release it to the world yet, but I will be releasing it to all of you next week. Not Thursday because I'm traveling that day, but sometime next week for sure. I will give that to you guys to work through as a challenge exercise to see how well you know navigating through a layer 2 network. The plan is then also to build another one for layer 3 networks, but that's for the future. For now, we're just going to stick with this one coming up, which is layer 2 networks. In any case, that is all I had for you guys today. I hope you guys enjoyed that lab walkthrough. Let's go back to this guy. Hope you guys enjoyed that lab walkthrough. Again, if this is something you want to see more of, please mention something in the comments. If there's a lab you want me to walk through, a lab that you got as homework, or a lab that you found online or something like that you want to walk through as homework, you want me to walk through and kind of talk my way through, please feel free to share those links as comments in this video. Yeah, and I'm happy to do this if this is useful for you. Cool. A few questions just came up. Awesome. Well, hello, Brandon. Welcome. I don't know if my chat was frozen. I hope you guys didn't ask that a long time ago. But in any case, Brandon, welcome from California. Good to see you. Dan asked if a DHCP server can be in the cloud. Yeah, there's nothing stopping. You can put a DHCP server wherever you want. The problem with the cloud is you're accessing it across the internet, so it's not going to be quite as responsive. So it might be a little bit slower to get IP addresses. But yeah, I don't see anything really that would prevent you from doing it using something like IP Helper. Now, I would caution you sending something like a DHCP request across the cloud. DHCP is not secure by any means, and that DHCP request and the ensuing DHCP response is coming back, clear text over the cloud from the internet rather. So it would be very easy for someone to say substitute the DNS server you're giving to a particular client as their DNS server, and now they can control all of your web traffic or whatever. So you could run it in the cloud. There is a security implication. Most of the time, I'll see a DHCP in real networks. I'll see a DHCP server set up physically in each premise where you have office devices connected, or at least accessible via some sort of VPN backhaul back to the headquarters or something like that. So that's how I'll answer that. Cool, Vamps. I'm glad you're enjoying the videos. Glad you're getting a lot out of them. That's awesome. If you're learning a lot, the best way you can kind of thank me for that is by interacting with the videos, liking and posting comments. All that helps the YouTube algorithm favor these videos and other videos I release and help it kind of show it to a wider audience. So if you're enjoying this stuff, please help me out by throwing comments on all the videos that I post. That would be awesome. Cool, awesome. Mark, glad you enjoyed it. Good luck running through it yourself. You'll obviously have this recording if you ever need a walkthrough. I should also mention Keith Barker did a walkthrough of all of his own labs as well, and you can access that at his channel. I think there's a link already in the description. If not, I'll make sure there's a link in the description for how to access both his playlist with all of the lab walkthroughs and how to access his channels. Cool. So Dan asks, if there's a DHCP on the route, why would you use the relay? The idea behind a relay is you might have a DHCP server. So I'll actually map it out. We'll use this color. Cool. So let's just say I have a switch over here, and then I've got a bunch of PCs over here plugged into my switch. And sorry, this is not going to be super neat. I'm drawing with my finger. You could absolutely have a DHCP server plugged in over here. So if this was your DHCP server, that could be plugged into that switch, and all these PCs can get IP addresses from that DHCP server. Now that's the way DHCP is meant to work. You get IP addresses for something on your local network. The problem is, what if your topology scales? What if you get a router over here, and then this router is connected to another switch with a bunch of different PCs, and this router is connected to another switch with a bunch of PCs, and this router is connected to another switch with another PC. In each case, all of these are going to be separate networks because they're different routers off of the, let's actually use a different color for that. All of these are going to be separate networks because they're different networks hanging off of the router. Sorry, I forgot to turn the screen share back on. All right, trying again. So let's talk through it. So here is a switch. Here's a bunch of PCs on that switch, and here is a DHCP server, a poorly drawn DHCP server. These PCs can absolutely get an IP address from that DHCP server on the same network as these PCs. But if your topology scales, if your topology scales and you add a router and you add another switch and a bunch of PCs over here, and another switch and a bunch of PCs over here, and another switch and a bunch of PCs over here, well, all of these PCs are also going to need a DHCP server, are also going to need to get IP addresses from a DHCP server. Now, one option is you could plug a DHCP server into every single one of these DHCP, almost misspelled it, into every single one of these switches. You absolutely could do that, but you can see how that doesn't scale. What if you grow to 10 networks or 50 networks or 100 networks or 1,000 networks? Instead, you want a way for there not to be a DHCP server on every single network, but to allow the PCs connected to all these forward networks to connect into a DHCP server that already exists. But DHCP as a protocol uses broadcast, which means if a host over here tries to get an address, it's only going to go as far as that particular network. What DHCP Relay does is you tell the router to act as a relay to receive those broadcasts and then forward them to the DHCP server. The DHCP server gets it, the DHCP server formulates a response and sends it back to the router, and then the router punts that back to the actual host that was actually asking for an IP address. The router is here acting like the relay for DHCP. It's receiving a DHCP request on one side, on this side, and then forwarding it to the DHCP server on the other side, and then passing it back on to the server. So the point of DHCP Relay is to allow DHCP on the other side of a router. Now, you absolutely could, if you wanted to. I would be unsure about whether this is recommended, but this goes back to your question. You could, if this router is plugged into the cloud, right? Oh, that's not what I wanted. I didn't want the disappearing ink. If this router is plugged into the cloud over here, and on the other side of the cloud, you had another router, you could absolutely have a DHCP server. What color did I? We'll go yellow. A DHCP server over here. DHCP. Can you guys see that? It's not in my face. Yeah. Okay. Cool. You could have the DHCP server over here, right? But those DHCP requests and responses going through the internet is not a good idea insofar as security, because anybody can then modify the responses that are coming through your network. So that's why typically at every physical location, like this could be an office building or something like that, you would at least have a DHCP server within that office building so that everything can get IP addresses local to the office, but not necessarily local to the actual networks of each device. So hopefully that explains that. So not necessarily, Dan, not necessarily to avoid double natting. Double natting is kind of a different, an unrelated concept, you could say. If you're interested in learning about double NAT, where I would point you to in that particular case, if you go to pracnet.net/nat, N-A-T, just hide that for a minute. I wrote an article series about network address translation that'll really teach you everything you need to know about how network address translation works. And one of those articles is policy NAT and twice NAT. Twice NAT and double NAT are generally used interchangeably. They're sort of the same thing. But this article will show you what exactly twice NAT is and why you would want to use it. And so hopefully that would communicate to you why it's not entirely related to DHCP. So again, pracnet.net/nat, that's the series landing page over here. Highly recommend that series. Cool. Well, that was some good questions. Any other questions for me while the stream is going? And Dan, let me know if that answered your question as well, please. Cool. Cool. Well, I'm not seeing any other questions, so I guess we will go ahead and close. So again, hopefully you guys enjoyed that. Hopefully you got a lot out of that. If you're interested in more content like this, definitely join us on the Discord over here, or subscribe to the blog. I'm happy to do this type of stuff for people who are learning networking and learning network engineering. The whole idea behind my brand, Practical Networking, you can see the title over here, is to make networking a practical thing, not just theory, not just memorizing a bunch of information, but actually showing you how things work behind the scenes. So hopefully today's session did some of that for you. So Dan asked, when are we meeting next? I don't actually know at the moment. I'm actually traveling a week from today when I normally do these on Thursday mornings. So it's possible we won't do one this coming Thursday, rather a week from today, but the next one will be a week from that. So 2 weeks from today. Either way, I'll probably post on the blog when I do the next one, because I'm also going to be releasing that packet tracer challenge lab that I'm giving away. So I will do a post on my blog when I do that. So look forward to that. There's a newsletter you can join if you want updates. I don't send out too many updates on the newsletter, just kind of when a bunch of new things have happened. So short answer, maybe in 2 weeks, Dan, but stay tuned on the blog if you want an update. Otherwise, if you have random questions about networking and want to see what's going on, definitely find us on the Discord. Oops, sorry, the Discord over here. I hang out there pretty often, and I'm happy to answer questions for people. Vamsy, I'm glad you brought that up. Go back to the screen share. So another resource I want to point you to is this guy. So I created this networking fundamentals video series, and it's meant to teach you kind of the very core of networking, how data moves through the network. A large part of the content in this video series is specifically geared towards passing interviews. The most common question you'll get in a networking interview is something like, you type ping google.com or whatever the case, or type google.com into your web browser, hit enter, what happens? Well, this series sort of takes you through all the things that need to happen to make that successful, if you will. So highly recommend that video series. There's only 10 videos out right now, but I think they're absolutely gold insofar as teaching you the core of networking, how switches work, how routers work, how the OSI model work, how IP addresses work, how MAC addresses work, how ARP works, all that fun stuff. Highly recommend this video series. They're all on YouTube. They're all free. Long term, this is going to be module 1 of a full networking fundamentals course, where I go deeper into the networking engineering career field. But for now, I just want to release the first module for free, just to see if people are interested in the full course. I'll just throw the link to the YouTube playlist. Oh, cool. I'm glad you asked. That's the question you got asked. It's a great question to kind of filter out to see if people really understand what's going on. But again, all of these are just on YouTube for you to watch and enjoy. I worked incredibly hard on this video series. In a lot of ways, it's kind of like, man, what did I wish someone told me when I was first trying to learn networking? Or how did I wish someone explained it to me when I first learned networking, before I had to just memorize a bunch of things and kind of figuring it out on my own self. So I'm very proud of the content of the series. Definitely check it out, make your own opinion of it. And if it's useful for you, spread the word. Tell other people about it. Tell your friends, tell your colleagues, post it on LinkedIn. That would be doing me a huge favor. Cool. With that said, we will actually bring everything to a close for the 3rd time. I hope you guys enjoyed this series. If you want more, feel free to check us out on the blog or the YouTube channel, subscribe, all that fun stuff, and then join us on Discord if you want to hang out further. I'll be there for the next 30 minutes if you have more Q&A you want to go through. Otherwise, thank you all for joining us, and I guess we will see you in the next stream or the next video. Have a wonderful rest of your days, and yeah, till next time, guys. Bye, everybody.